Oh, does it show the name that I gave to the meeting?
It does. It does. I was like, wow, I didn't put that in. Most of the time, mine doesn't have that fancy name. And oh, there we go. That's our video come up now. So I've got the chat over here on this screen in case we need to pop anything in there. Which we probably will in a minute. But welcome to Data Science Club number something. I can't remember what number we're on. But today we're going to talk about using Python and pandas and GeoPandas, which is like a mapping data frame utility to make some of those fancy world maps of the spread of coronavirus, since we're all still dealing with that. And so, yeah, so we'll go ahead and get started.
Yeah, and we thought that that was a relevant topic nowadays, and you guys would have seen different sites where they have the world maps where they show how the coronavirus started spreading. And so we thought that we found an article on Medium that was discussing that, and we thought that that would be a nice concept to show to you guys how you can create your own maps and include them in an article.
Yep, absolutely. So I'm going to paste all the links that we're using in here. We're actually not going to be looking at the Medium article directly. We're going to be looking at this GitHub repository that has all the code from the Medium article in it. But the Medium article is a good reference and kind of talks through a lot more of the back end than we'll most likely be able to get to here today. So let's see, I'm going to go ahead and copy the link to the repository. So I'm going to copy that. And then now I'm going to come over to rc.uab.edu. I've already logged in. So this is the portal to the Chiha supercomputer that we've got on the UAB campus. And I'm going to, let's see, I'm going to come to clusters and then Chiha shell access, because the first thing I got to do is get this code someplace. So I'm going to go to data user, my Blazor ID, and rc-dsc. That's a directory we've been keeping these things in. And then I'm going to type git clone and put in the URL from that repository. And then it will clone all of that code from that online repository and bring it down into my local space. So now if I list the directories, I have a coronavirus data science directory, and I can go in there and take a look at it. We decided to do it this way rather than going from the article, because this repository has a bunch of the sample data already inside of it. And so that makes it easier. We don't have to go searching for that. At least not hopefully. Hopefully it'll all work.
Yeah, and we also decided to go the command line version for cloning the Git repo rather than giving you guys a job or shell script that does that for you, because we think by now you should have become a little familiar with Git. If you find that you cannot copy down or you cannot clone the Git repo on your Chiha space or on your laptop or something, then do send us a comment and we should be able to help you in cloning it down to your personal profile or space.
Yeah, absolutely. All right, so now that we've done that, we're actually, oh no, we still have one more thing to do, but I think we can do that from the Jupyter Notebook side. We have one library we need to install, so we'll do that. I'm going to leave this terminal. I'm going to come over to interactive sessions, and I'm going to start up a Jupyter Notebook. I don't need it for 12 hours. We'll put it for 1. and we'll go ahead and launch that. Oh, I didn't put it in the right directory. Let me put it in the right directory. rc-dsc, and then that'll get me close enough. After that, we should be able to find that coronavirus data science directory. Let's refresh this. All right, sweet. We got it running. And now I'm going to connect to it.
Well, our other hope is that you'll learn the virtue of patience.
Yes. Yes, yes. I only ever run into that screen when I'm trying to show stuff to somebody else.
No.
All right, so I can go to this coronavirus data science folder. And you were saying it looked like the spread one was a better one to start out with. So we'll go to the spread notebook. Now, we already know that we don't have inside of our environment GeoPandas. So first of all, I need to change our kernel. So I'm going to change the kernel to, let's see, what is it? NBOTW. And then I'm going to create a cell. I think this is going to work. I'm going to create a cell above this top one for me to install GeoPandas. And let's see. I think if I just do pip install GeoPandas, I think that will work.
Yeah.
Or would it be better to use the conda command?
Pip should be okay too.
We'll give that a whirl, see if that works. All right, so by putting that exclamation point in front of the code, it says, instead of trying to run this command in the Python language, I want you to go and run it on the command line and then show me the results of that. So it looks like it went through and it correctly installed.
Yeah, and since William already changed the kernel to NBOTW, if you'll see at some of the paths, you'll notice that where the requirement is already satisfied and where it's keeping those things, you'll see that it's in the NBOTW environment that it's looking in if a package has already been installed and where it should go ahead and install GeoPandas and all the dependencies that are not in his environment right now.
Yeah, no, absolutely. All right, so pandas we've worked with before. It's kind of a data manipulation library. Matplotlib is for plotting. GeoPandas is the one we just installed. We'll use that in a minute. NumPy for math, Glob for managing file system stuff. Datetime for managing date times. And then geodata functions is a module that the author of this Git repository actually wrote. And we can take a look at that real quick. Let's see. I'm not entirely sure what all this is supposed to do, but it looks like it's dealing with a lot of the data cleaning aspects of dealing with this particular data set.
Yeah, it cleans up the data and at the end result sends you a data frame. So we should be using these functions within our Python notebooks, like this build env geodf somewhere in our Python in our Jupyter notebook.
Mm-hmm.
And that's basically just showing that if you are going to be running a same set of code multiple times, like if I have 3 different sets of data and I want to do the same functionality with each of them, so that at the end of it, after cleaning up, after all the parsing and everything, I have a data frame in the end. It's better if I build a function that I can keep using again and again. So you can make the function directly inside your Jupyter notebook, or you can have another Python script in the same path or somewhere else where you are actually writing those functions. And then from within your Jupyter notebook, you can call call the Python script and its functions.
Yep. Yeah, absolutely. Absolutely. All right. So now we can come back to our notebook. And so this first thing, so this matplotlib inline just ensures that our plots are going to show up inside the Jupyter notebook. Files, this is creating the list of all of the data files in that data directory. And then columns, this is going to directly specify the names of the columns here when we actually do the read CSV that we want to keep from the data. I'm assuming the data has more columns than just these 4, but these are the columns that we're going to keep. And then by saying data dfs dot append, we're making a data frame that becomes even larger with each new CSV file that we pull in. Yeah. And then at the end, we're going to do df equals pd.concat dfs. And so this is just saying take, okay, because what it's doing is creating a list of data frames.
Yeah.
And then after I have my list of data frames, I want to concatenate that list together into a single data frame called df. And then I want to print out what that df is. So let's see how that looks.
Yeah, if you see the last line, it's basically how you write. If you want to write 2 different sets of commands in a single line, then you have that semicolon in between, and it's going to take everything before the semicolon as one call or one task, and the second one as a second task.
Yeah. All right. So yeah, so now we've got that in here. So now we're going to do some data cleaning. So we want to, okay, so this is part of what that, those functions were in that geodata functions that we pulled in. Is this changing of identifiers. And I think it was this states abbreviation to full that that was in there that we're using here. And so this just goes in and changes everywhere where we see a city plus a state to just the state. So like here we see Los Angeles, California. I think this is changing that to just say California.
Yeah.
But we can run that and see what that looks like. Let's actually look at the data frame again, just to verify that that's what it's doing. Yeah. So instead of saying Los Angeles, California, it just says California now.
And this is needed because since we are showing a world map, identifying California would still be better than identifying Los Angeles. Because you might not just see that dot anywhere. If you count the LA as California and then San Francisco as California, then everything would get added up from LA and California, and it's easier to show California state.
Yeah. Yep. All right. So now this next part is we're creating location function. And that's in this geodata function. So let's see. All right. So I gotcha. So this is just making a location that's the sub-region, like the state, plus the country in one string as the location. So like California, US, or Hong Kong, China. All right, so we can do that. And we can actually print out that locations just to double check. Yeah, so that's what that's doing. Okay. All right, so now create a range of dates covering the first and last readings. We'll use this to create individual time series. Okay. So yeah, so this makes the range of dates that we have data for. Okay. And then time series. All right, so now we want to build a time series for each location using the dates in the date range, because we want to build ideally a progression of colors in these states, so that like on January 29th, it might have one shade of red. And then if there are more cases on February 2nd, that shade would change.
Mm-hmm.
So that makes sense. All right. But does that mean we've got, all right. Yeah, so this is what I was interested in. So now build a single large data frame for confirmed cases with the dates as the index, and then the locations as the column names. So this is taking each location and putting it out as its own column, and then each date is its own row, and the number in here is the number of confirmed cases on that day.
Mm-hmm. And this is not the entire data set. It has other countries, but we are just showing these 4 countries now, right now.
Yep.
4 locations right now.
Yep, absolutely. All right. So, all right, we then need to bring back the province, state, and country region to join the GeoPandas data frame. Okay. Okay, because I guess the GeoPandas data frame is going to have province, state, and country/region in it. And so we still need those 2 columns to be able to join the 2 data sets together. Okay. All right, geo data frame. So merge a single day of data with GeoPandas data. Okay, that makes sense. And this build ncov geodf is taking the data frame and then adding the shape information and the geometry information for those locations into this geodata data frame, or GeoPandas data frame. Okay. Okay. So now we're building a map with a single day's worth of data. Oh, no module found named Descartes. Where is that being used?
Surprisingly, I don't see.
Oh, it's Pandas, or GeoPandas relies on it. It's interesting. I wonder. All right. Well, we'll go ahead and see if we can install that. I wonder why the pip install didn't add that one.
Yeah, if it was a dependency.
Okay, let's try it now. Okay. So there may have been more cases on January, what was it? January 21st than what's showing here, but these are the confirmed cases. So it's pretty cool. All right, and so then we can plot the most recent day that we have. And I don't know what day that is. Oh, okay, so February 4th. It's the most recent day that we have. If you wanted to, you could use this function in here, this pull G sheet. Apparently there is a Google spreadsheet with this data in it that's maintained. But we're just using the data that was already pre-downloaded right now. All right. So then if we wanted to create a animation, that's what this block of code is for. Let's see. Oh, uncomment to save images locally. Okay. Oh, file not found. No such file or directory out.
Oh, we might need to run that thing. Yeah.
Do I have to make a, what do I got to run?
Yeah, I think we might need to run the.
Oh, to generate an image.
Yeah. Yeah, we might need to run this on the terminal or with the exclamation mark.
I gotcha. So let's see if that will actually do something. Unable to open. Let's see what happens here. There's no folder named out.
That's interesting.
So I think I've got to create a folder named out. And then I've got to rerun this part because that'll make all of the individual images. Yeah.
So comment out the last one. I think both of them are creating ncurve.gif. One is for Twitter. So I think it might be more vertical video kind of thing. And
that makes sense. All right, so let's see if that's making, yeah, so that's making, that's why it's taken a while.
yeah, it should almost be done. There weren't many days anyways.
Yeah. Yeah, it looks like we're done.
All right, and now we should be able to create that GIF file.
Yeah, so now if I run this, let's see how that works. Maybe the CD command doesn't work super great. Let's just try, I'll copy that. We'll open a terminal from here. And then go CD data user WS Monroe RC-DSC coronavirus DS out, and then convert. Okay, perfect. And so now if I come here,
We have the at the end.
Yeah, I have it right here at the end, and it works. That's cool.
Yeah.
Yeah. Yeah, that's pretty nifty. So, all right, well, cool. So I think the key takeaways here is that for visualizations like this, GeoPandas can help you out to make these kind of visualizations with the maps. It doesn't have to be this coronavirus data. But it looks like there's a little bit of fiddling in the background, and maybe we'll do something later with what that fiddling in the background looks like. But it looks like it's a pretty powerful tool for being able to develop geographical visualizations.
Yeah, and I would suggest one of the scripts that William was showing earlier from the Git repo. I forget the name of that script that should bring in the latest data from I think from Google Sheets or somewhere, and so that you don't have to be stuck till February 4th or 5th. That's the data that already comes with the Git repo. But if you run that script, it's just going to update it till the latest. So you should have data till
Let's see.
June.
So do kind of activate. Let's see. Let's see how long it takes to pull that in if we run it. Oh, no. So apparently you've got to like download the Google API and all this sort of stuff too. So we won't worry about that right this minute. But assuming that we did that, we should be able to pull that data down, no problem. So I don't know, thoughts?
Yeah, that's basically it. It's a good method of seeing what you generally see on some websites, some news websites and all. And if you are curious how they're able to generate these data and how can they create GIFs on how the COVID case has spread, I think this is a good exercise to see how you can create something for yourself. And you don't have to stick to COVID data. We thought that is relevant, and that was the data set that the Medium article was using, but you should be able to use some other data sets as well.
Yep.
I'm not sure what data sets, but you can use other data sets.
Yeah, absolutely. All right, let me see if I can stop the share. All right, well then until next time, we'll see you guys next week.